Okay, so that was the video of making a free shot. And here will be how it looks like on the graph. And this is when it leaves my hand, and this is when it goes through the rim. So apparently, we know that the distance between the free throw line, which is the point I throw to the basket, will be 15 feet. And we also know that the basket, the distance between the rim to the ground will be about 10 feet. And where I throw it is about like 5 feet from the ground. So we are going to say the for the position vector, x will be 0, and since that's where it starts, and y will be 5, since that's like about 5 feet from the ground. And for the end position, we're going to say that the x will be 15, since it traveled 15 feet from where it is started, and the y will be 10, since that's 10 feet from the ground. And we know that the lap time is 5 seconds from the video, and we also know the acceleration vector in general for this kind of throw, the dy to d2y dx2 is 0, and d2x dt2 will be 0, and d2y and dt2 will be negative 32 due to the gravitation. So for the v vector of x, we know that 3 feet per second, and it's a constant 3 feet per second because the vx doesn't change as it go from the beginning point to the end point. And we can get a vy by integrating the acceleration. So we have negative 32t plus c1. So far we don't know what c1 is yet, but we will get back to that later. So about the position, sx, where is about for sx, we basically integrate the vx. Therefore, we have a sx is 3t plus c2. And we know at the starting point, which is when t is equal to 0, the 3t plus c2 is equal to 0. Therefore, we know c2 is 0, and sx will just be 3t. And for sy, we integrate whatever the vy we got, which is a negative 32t plus c1. So that we have negative 16t squared plus c1t plus c3. So we know at the beginning, which is t is equal to 0. When t is 0, the sy will be 5. Therefore, we have c3 equal 5. And we also know that at the end point, which is sy when t equal 5, is 10. And by calculating this, we have that c1 is 81. So basically, we plug 81 back for c1 and 5 for c3. That's how we get oh, that's a mistake. Shouldn't be here. Should be here. That's how we get a formula for sy. And since we also have y1 now, we also know that vy will be negative 32t plus 81. Yeah. Therefore, we can conclude that the vt is equal is 3 comma negative 32t plus 81, and st will be 3t comma negative 16t squared plus 81t plus 5. Okay, so the equation at tangent line for this one, let's say t is equal to 1 second, and yeah, when t is equal to 1 second, we know the tangent line equation is dy dx is equal to dy dt over dx dt. Basically, that's vy over vx. So we have negative 32 plus tan in this case, which is 1 second, plus 81 divided by 3 times the tan 1, and we have the dy dx 16.333, and using the position vector to calculate the position, we get we got S1 x equals 3 and y equals 70. Therefore, the tangent line equation at time equal 1 will be y minus 70 equals 16.333 times parenthesis x minus 3. So speaking about the speed and direction, this time we are going to say t is equal to 2 seconds. So when t equal to 3, the dx dt will be 3 and dy dt will be 17. So in order to find out the direction, we arctangent the the dy dt over the dx dt, and that's how we get 1.396 radian. And in order to figure out the speed, we are going to square root the 3 square, which we get from here, and 17 square, which we get from here. And the number we get at the end is 17.263 feet per second. And the total distance traveled by the ball from the moment I leave my hand to the basket will be calculated from 0 to 5. 0 is the starting time, and 5 is the time when it goes through the rim, and we got 3 from the velocity, because that's the dx dt, and we have to square it here, and we also have a negative 32t plus 81, which we get from the dy dt here. We also have to square it, and we square it with the whole thing, dt. So by typing this into the calculator, we should be getting 201.290 feet. Thank you for watching.